Hello, I am Zeke Wheely, and this is my final project over the Utah mountain kingsnake, whose scientific name is Lampropeltis pyromelana infralabialis. The Utah mountain kingsnake's species ecology. Its preferred habitat is in wooded areas where it can hide under rocks, logs, and in crevices, and as the name suggests, they are found in mountains, typically at a range of around 5,500 to 7,500 feet in elevation. And they will be commonly found near water sources. As well, they are an edge species, so they are commonly found in ecotones. Here's my species distribution data. I acquired this data from iNaturalist, and the dates that they occurred from were from 2010 to 2025 with 111 observations. For land cover, I have created a cropland data layer that consists of Utah, Nevada, and Arizona. Few observations are found in Nevada, and I think only one was in Arizona, majority being in Utah. And there were 111 observations from iNaturalist, but after filtering, only 89 points remained. The buffer zone I chose was 121 meters, which represented the daily movement distance. I chose this because I wanted to see mainly how they were moving around the edges of these patches. This map shows my reclassified cropland data layer with the 5 buffer points seen in purple. The green zones represent places they could inhabit, while gray zones are non-inhabitable. My 5 buffer points were randomly selected at 7, 17, 57, 73, and 79. I guess I have a lucky number 7. For landscape metrics, I have elected to use the 8-cell rule rather than the 4-cell rule when it comes to infralabialis. Since it is a species of snake, I thought it provided a more realistic representation of the snake's movement through the landscape. Since snakes do not tend to go on a straight path since they slither on the surface of the ground, they tend to veer, so I think the 8-cell rule would provide a more realistic representation. For my 3 C's, for composition, I chose percentage of landscape using pland at a landscape level, total class area TCA at a class level. For configuration, I used total edge TE and split both at class levels, and the shape index standard deviation, shape SD, at landscape level. For connectivity, I only use radius of gyration through gyrate at a patch level. Here's my data set that I obtained using gyrate, PCA, and split, but on a later slide, I have compelled them into the means, which you will see. Here are my other data sets from total edge, keyland, and shape SD. Here are the results of all the datasets compiled into their means and average shape SD. I will go into further detail on these in the next slides. Now to address the land cover. Overall, 3-state focal area was mainly dominated by shrubland at 70.1%, evergreen forest at 13.47%, grassland pasture at 6.05%, barren at 4.56%, deciduous forest at 1.41%, and all other land cover types were less than 1%, with a total of 84 total land cover types. Now, if we go to my 5 buffers, there were only 4 total land cover types that were seen. Shrubland being the most dominant at 55.22%, evergreen forest at 38.1%, barren at 5.88%, and deciduous forest at 0.8%. Interpreting the results of composition. When using peatland, within the buffers zones, shrubland and evergreen forest represented the majority of land cover, with a mean of 55.2% and 47.6% respectively, while barren and deciduous forest were underrepresented with a mean of 29.9% and 4% respectively. When using total class area, values were greatest for shrubland at 0.99 and evergreen forest at 0.85, which indicate a higher absolute habitat availability. The conclusion for this would be Infralabialis showed strong association with shrubland and evergreen forest within the buffer points. However, shrubland is not a preferred habitat of Infralabialis, while the forests are both evergreen and deciduous. However, deciduous forests were very underrepresented, being only 4% at the mean. Interpreting the results of configuration. Using split, deciduous forest had a high mean split of 625, which indicates a very small isolated fragments. However, in evergreen forest and shrubland, they were relatively fragmented, but still maintained functionality with values of 194.5 and 134.1 respectively. While barren was not very fragmented, it had a value of 13.2. For total edge, barren had the highest total edge value at 479.99 meters, with shrubland and evergreen forest following at 389.99 meters and 352.49 meters respectively. Now, using the shape index standard deviation, the average was 0.220, showing moderate patch shape complexity. Now, for the conclusion, Infralabialis in the buffer points were typically found in moderately fragmented patches with lots of edges. And this makes sense because they are edge species, so being around patches with lots of edges is something they typically want to do. Interpreting the results of connectivity. The only metric I used here was gyrate, and in shrubland had the highest functional connectivity with a mean gyrate of 50.42 meters. Evergreen forest patches moderately connected with a mean of 31.46 meters. Deciduous forest and barren had poor connectivity with a mean of 21.21 meters and 21.23 meters respectively. The conclusion for this would be Infralabialis are associated with land cover types that are relatively well connected and allowed moderate within patch movement. Interpreting the results of context. For most of the occurrences of Infralabialis, within shrubland and evergreen forests, they were found near the patch edges. However, not many of the occurrences were found in the deciduous forest or barren land cover types, even though deciduous forests were much more fragmented and they are edge species. Why might this be? The conclusion may be that Infralabialis utilizes ecotones for foraging, thermoregulation, or habitat, or a combination of all three, or even more, when those land cover types are shrubland and evergreen forests, but not so much for barren or deciduous forests, either because they are too fragmented, which may increase risks such as predation, since they are at the edge of the land cover types, or those land cover types do not have the proper resources, such as barren not having enough logs, rocks, or crevices for them to inhabit, which they prefer to. They may not have the prey that Infralabialis preys on, or there might be predators in those land cover types that Infralabialis is trying to avoid. And here's a little slide to end off my presentation. What did the edge species say to the area sensitive species? They said, don't be so sensitive.